When a function finishes running, its local variables are supposed to die, but a nested function returned from that function can still access those variables, and that's known as a closure. Let's say we have a function called makeCounter, which defines a variable, count, and returns an inner function that increments it. In most languages, functions are lexically scoped, meaning a function can see the variables in the environment where it was defined. So if you define a function inside another function, the inner one has access to the outer one's variables. But here's where it gets interesting. What happens when the outer function finishes and returns, but we've held on to the inner function? Normally, the outer scope would be garbage collected and the local variable would be gone. But if the inner function is still alive, it keeps that scope alive with it. So calling counter, even after makeCounter has returned, still keeps the count variable alive and increments it properly. Now, what happens if we call makeCounter twice, getting counter A and counter B? If we call counter A 2 times, it counts to 2. Now call counter B and it goes from 0 to 1. They each have their own private copy of count, completely independent of each other. Now you may have noticed something. We have a private variable with a function that operates on it. Sound familiar? That's basically a class. Here's the closure-based version on the top and the class-based version on the bottom. In fact, JavaScript didn't have private class fields until ES 2022, so closures were the idiomatic way to get private state. Classes are more natural when you're modeling an entity with multiple behaviors, while closures can be useful when spinning up an entire class feels like overkill. And if you're working with JavaScript written before ES 2022, closures are everywhere, so now you know how to read them.